Welcome, students. This is your last lesson in factoring. This is called Quadratic Equations, Perfect Squares. We're going to start off the first part of your lesson. You're going to be asked to determine if a trinomial is a perfect square trinomial. You're right, yes or no, and then if it's a yes, you're going to factor it. Well, there's three things that you have to check to see if it's a perfect square trinomial. The first two are, is the first and last terms perfect squares. So in this one, the first term's a perfect square, the last term's a perfect square. The second thing you have to check is about the middle term. Factor out or take the square root of the first and the last term. So it would be 3y and a 4. Multiply those two together and then double them. So 3y times 4 is 12y, and 12y doubled is 24y. So then that checks out. This is a perfect square trinomial. So now we'll write yes, and then we'll factor it. The factoring's the easy part. You can write the answer two ways, as two binomials or as one binomial that's squared. And we'll have 3y plus 4 in each one. Because they're identical, you can just write it once with the square term. Either of these answers, this one or this one, are exactly the same and very acceptable. Okay, let's do it again. Is the first term and the last term perfect squares? The last term is, but the first term is not. So this is a no. All right, first and last terms perfect squares. Yes, yes. So let's take the square root, be 5x and a 6, and then double it. 5x times 6 is 30x. 30x doubled is 60x. So the middle checked out. Now we'll factor it out with the yes here. And again, you can write it twice, or you can write it once. It'll be 5x and a 6, 5x plus 6, or 5x plus 6 squared. Either way, you can write that answer. Okay, let's check the next one. 9x squared is a perfect square, 4 perfect square. Now let's square root and check the middle term. 9x squared square root is 3x. 4 is a 2. Then we got to double it. 3x times 2 is 6x. 6x doubled is 12x, not negative 6x. So this is not a perfect square trinomial. So it's a no. There's our answer for that one. Because the middle term did not work. All right, let's keep going now. All right, the middle part of your lesson, you're going to be asked to factor the polynomials. Now, you've been taught several different ways to factor. We can factor by sliding and dividing, by perfect squares, by difference of squares, and just factoring out a number, a term. Any of those ways means you can factor it. If you cannot use any of those methods, you write prime. So let's get started. First one, I see immediately I can factor out a 2. So I'm going to do that. It's going to leave me x squared minus 16. Then I see difference of squares. So the 2 will stay, and I will factor a little further. X minus 4 and x plus 4. Now I'm finished at this point. Okay, the next one. See if there's anything I can factor out. No. Let's see if it's a perfect square trinomial. The last term's a perfect square, but the first term is not, so it's not a perfect square trinomial. And it is in the form of ax plus bx equals c, ax squared plus bx equals, or plus c or minus c. So we're going to have to slide and divide. So here we go. We're going to do the 12 times 25 first. So we'll have x squared plus 5x minus 300. 12 times 25 is 300. Now we'll see if we can factor this out with x in each one. This is going to be 2 factors of 300 that subtract to get 5. Now right off the back, if you try 30 and 10, if you subtract those, you get 20. So it's got to be smaller than 30. Now 25 and 12 won't work either. So smaller than 25. Let's try 15. 15 will go into 20 times. So it's 15 and 20 because you subtract them, you get 5. So this does factor. And our bigger number has to be positive because our middle term's positive. Now don't forget, slide and divide. You have to do the divide part. So you bring the 12 around here to divide it. So it's 15 divided by 12 and 20 divided by 12. Now we're going to simplify, reduce if we can. And when we reduce 15 over 12, divide by 3, we'll get 5 over 4. And this one, divide by 4, we'll get 5 over 3. And now we have to take our denominator and put it in front of each of the x in each binomial. So we'll end up with 4x minus 5 and 3x plus 5. And now it's factored. That one was a tough one. All right, next one. First thing, can I factor out a number? Yeah, I can bring a 4 out. So bring that 4 out, you're going to end up with x squared plus 16, actually. 64 divided by 4 is 16. And that means we finished that one because that can't factor any further because this is not a difference of squares. There's a plus here, so you don't see the subtraction. So this does not factor any further. Okay, let's go to a few more. Okay, and this one, let's just check, see if this is a perfect square trinomial. First one's a perfect square, last one's a perfect square. This one would factor to 2x and this to a 4. So let's see if we multiply those together, we get 8x doubled 16x, so no, that didn't work. So it's not a perfect square trinomial. Darn, that would have been easier. So now we'll do slide and divide. Okay, we'll start out, we'll get x squared plus 9x minus 64. And we'll see if this will break into two binomials now. X and x. Now what are the two factors of 64 that will subtract to get 9? And there's not going to be anything because there's 8 and 8, that makes 0, and 4 and 16 make 12, so this is prime. It won't factor any further. All right. Next one, and like I said, guys, you just got to try all your different methods that you know. Is there anything I can factor out of this entire thing? And yes, I can take a 2 out. So we'll be left with 3x squared minus 17x plus 24. Now at this step, let's see if this trinomial will factor any further. And we can't take anything else out. It's not a perfect square trinomial, so let's go to slide and divide. So let's take our 3 and multiply it. The 2 stays out here. We get x squared minus 17x plus, okay, and 3 times 24 is 72. Now we're going to break that down if we can. The 2 out front, we'll have x here and x here. Now we need two factors that multiply to make 72, but since it's positive, they'll both, and the middle's negative, they'll both be negative. Multiply to make 72, but add to make 17 would be 9 and 8. Now we take the number we slid, and we're going to bring it around here to divide. So 9 over 3 and 8 over 3. This does simplify, so it'll be x minus 3. But this one, the 3 needs to move over here in front of x, so it'll be 3x minus 8. So this one simplifies all the way down to that, or factors all the way down, I should say. Now, I've done quite a few. It's just the same process. Look for numbers you can take out. Look for numbers, perfect squares that you can factor away. I'm going to jump on down to the bottom part so I make sure I show you some of these examples. Again, when you're solving these equations, you factor them down as far as you can. You set everything equal to 0 and give me 1 to 2 to 3 answers depending on how many it will break down to. The first one here, we have a perfect square here and a perfect square here. This would be A, this would be 6. What's 6 times A is 6A doubled, would be 12A. So this is a perfect square trinomial. So we're going to go ahead and factor it. It'll be A plus 6 squared equals 0. So that means it's the same answer. A plus 6 equals 0, and A plus 6 equals 0. So you have one answer this time. When you solve it, A plus 6 equals 0. You subtract your 6. So A is only -6. You only have one answer when they're a perfect square trinomial. All right, in the next one, let's take everything over to the side where it's 4x squared minus 80x plus 400. And then we're going to take a 4 out of the whole thing. So we'll get x squared minus 20x plus 100. Okay, so let's factor this on down a little bit further. 4 out here. Factor this into two binomials, so you have x and x. Two factors of 100 that make 20 would be 10 and 10. They'll both be negative, because it makes a -20, but a +100. And now to solve it, you have to set these equal to 0, and the 4 equals 0 doesn't work, so the 4 will be a solution. But x minus 10 equals 0. Bring the 10 over to add it, so x is 10 only. Again, one answer, because they're both the same. All right, we can keep going and keep going and keep going on these, but I want to show you a couple of specific problems. I'm going to start up here with this one. When you have two perfect squares on each side of the equal sign, you don't have to make them say equal 0. In this case, use the square root function to factor. And let's take the square root of each side. The square root of a minus 10 squared is a minus 10. And the square root of 121 is 11. Now, and of course, by the way, though, it's not just 11. The square root of 121 is a positive or a negative 11. So that means you have two possible answers here. You have a minus 10 could equal a positive 11, or a minus 10 could equal a negative 11. When you solve them, add 10, a could be 21, or add 10, a could be -1. So this has two answers. And remember, you have to put that positive or negative in front of 11, because it could be either positive or negative. And let's go on down to a few more that work similar. Again, we're going to use the square root method on this one. Even though 7's not a perfect square, this is what's going to happen in this case. To unsquare this, it's y minus 4. But the square root of 7 will stay like that. But it'll be a positive or a negative square root of 7. Because it's a decimal. 7 does have a square root, but it's this long decimal. So we're going to put a positive or negative in front. Then we're going to solve it. We're going to say y minus 4 could be a positive square root of 7, or y minus 4 could be a negative square root of 7. But here's a shortcut. Instead of writing it twice, when you add the 4 over, it'll be a positive 4. So just write it like this. The answer for y could be 4 plus or minus the square root of 7. Just keep that plus or minus there. You can totally forget this middle step and write your answer just like that. I'm going to show you again. Give me some room here. That middle step out of the way. Again, we're going to take the square root of both sides. 26 is not a perfect square, so we're going to leave it under the radical. C plus 3 is the square root of c plus 3 squared equals the square root of 26, but don't forget positive or negative. So then when we bring our 3 over by subtracting 3, c would be negative 3 plus or minus the square root of 26. And there's your answer. One more time to make sure you've got this down. Square root, square root. C plus 5 is the square root of the first one. And then it's a positive or negative square root of 47. So we bring the 5 over by subtracting it. So the answer is Z is negative 5 plus or minus the square root of 47. And these are finished. So there's several different ways to factor that you've learned. Just try to remember them as you apply to all different types of problems that you will see. And I'll see you in class.